So my name is Michael. I'm here to talk to you today about supporting your architecture through code coverage and static analysis rules, based on some things that I've gone through my experience over the last few years, different projects, different teams that I'll go into in a second. So this isn't really going to go into too many low-level details of implementation, but more sort of a higher-level approaches, things that work, things that maybe don't work, to really try and hopefully make things better for everybody involved in an engineering team. Now, just coming from a place of assuming no knowledge in the audience, if we start looking at code coverage, which is sort of the primary focus of this, sort of have the definition of, quite simply, what percentage of your code is covered by automated tests. We might think of that as unit tests, UI tests. The most common tool we use to measure this on Android is Jacoco, something that quite a few of you have probably encountered or heard of before. And these tools, there's other tools that can sort of read Jacoco reports or other code coverage tools of your choice, can often be integrated into build processes to provide feedback, say what kind of code, what's changing over time, what's being tested or not. So why do some people like code coverage? And I put some people in brackets because what I've at least found in my experience is, at least sort of in its most basic form, code coverage is normally liked by more sort of, I'll just call them management figures. And it becomes quite popular because it can be used to represent code quality. If you're looking for something to kind of answer the question, how high quality is our code? And you can say, well, here's the code coverage. It's quite a useful metric to use. It's a very easy number to understand on a scale. So you have 0 to 100, where low, if you say you have a code coverage of 0, that's not good. A code coverage of 100 is quite easy to say that is good. So you can end up with something, very basic like this. You just have number over time. And that's why, if you're looking from a very high level, it's very easy to look at this and say, oh, why did we have this dip? Why is it increasing? And, whilst having something clear to measure sounds good, even for an engineer, I've been there myself thinking it's actually nice to have these things that you can measure yourself against, to measure the project against. There's a lot of reasons, particularly on Android, why this 100% coverage is not realistic at all. I think it's unrealistic on any project, but particularly given some of the complexities that we all know about, it's not a good target. And what I found in my experience as well is if it's not managed correctly, this sort of code quality, code coverage metrics can very quickly become an us versus them issue. You never want to be in a situation where you have some people saying, this is a metric, we need to get it to 100. You're there saying it's impossible, but it's being measured anyway. And so you end up sort of trying to game the system, this sort of, well, we're trying to satisfy this because management want us to, but we don't really believe in it. And that really reduces the value. And this has even become more so in the last few years. So, I was looking at this, it's kind of funny, it's like I'm giving a talk on code coverage to DroidCon, and actually if you look at all of the articles that have really come out in the last few years, you have articles like this: code coverage complications, why code coverage is a lie, why test coverage targets are a bad idea. I can keep on going on. It's a useless management metric. Is it useless? Don't use test coverage as a target, the case against it, and my favorite, how 100% code coverage is destroying applications. And these are all things that have come out literally in just the past 2-3 years. It's sort of become this big movement. And so why am I talking about this? Why am I standing here when I've been reading these things myself, my background is an Android engineer for the past 10 years or so, moved into more of a tech lead role. I was reading all of these and sort of starting to believe in it. So why am I here now talking to you about the very thing that I've just been talking against? This was because my director, to me, in late last year, kind of gave me this goal and said, hey, I want you to work on a strategy to increase our code coverage. There were lots of reasons behind this, obviously very simplistic, putting it on a slide like this, but this was actually what I was tasked with doing. I work on the mobile platform team at Skyscanner. We work across about 8 feature squads primarily, and so I was tasked with how can we actually roll this out, get something meaningful. And basically for me, my personal challenge was, how do I avoid everything that those articles are talking against? So I just wanted to spend a few minutes today talking through some sort of very high-level techniques that I found have worked for us, hopefully give you, if not some direct ideas, some sort of inspiration on how you can actually get this not only to just work as a code coverage metric, get something, ultimately providing what was asked for, which is what is the code coverage, but how you can actually use this as part of a wider strategy to sort of enforce architecture, really get the engineers all on the same page. So I'm going to start by sharing what's worked, and just, short disclaimer, as I said at the beginning, we did already have some of this set up in CI/CD. If you Google it, there's lots of popular tools online, lots of guides on how to get this set up, both through paid-for tools, cloud tools. So I can give some ideas afterwards. I'm not going to do a sales pitch for any of them, but so this is, coming from a place that you have a way of measuring code coverage already, or at least some capabilities where you can easily add this. And the very first thing I'm going to talk about is almost one of the most basic when you first say it, which is using inclusion and exclusion rules. Again, this is very simple definition. It's deciding what should or shouldn't be included in the coverage calculations. You've most commonly seen this. If you've used these sorts of tools before, you can normally add a comment or a certain annotation at the beginning of a file or beginning of a method which says, don't include this. And that's sort of the most simple form you might use. If you've got a particularly difficult, a static class that just wraps an external third-party SDK that you're using, it's impossible to test, so you say excluding it. But what we found is this can actually get really powerful if you start combining it with your target architecture as well. So what do I mean by this? If we take, for example, the sort of typical MVVM, maybe you've got this sort of structure where you've said, okay, this is what I want for my features in the code base. And we sort of know, again, using quite a simplistic example, but as most of us know sort of from using this architecture, you have the model, and the view model is where you want your business logic. That's where you want things to be tested. The view maybe not so much, there's a point of sort of taking that away, should be quite simplistic. And so you might start writing at the very beginning a sort of exclusion rule. Again, it's this sort of pseudocode, so syntax will vary, which actually says anything in the view directory does not need to be included in the code coverage. If you follow sort of an architecture pattern where you have contract modules, I can recommend a great talk from Joseph Raska last year on sort of the use of this if you're really interested, a sort of way to improve your build times, improve modularization. You could have a rule that says, okay, well, the contract modules that we're having, again, should just contain the basic interfaces that are exposed. And so now I'm going to add an exclusion rule because I only want the sort of implementation code to be tested that excludes this. Because, again, you shouldn't really need to be focusing your time on what's there. The interfaces should be really simple. And already, if we start looking at this file, at the beginning, it might maybe not seem, okay, well, what are the benefits here? But you can start adding some comments. You can start looking at what doesn't need to be tested. And the sort of benefits that this starts to give you as well is that you start to actually know, well, what is the code that needs to be tested? What actually matters to us? This list should be checked into source control. And the most important thing with this should be written by engineers. At Skyscanner, we had multiple sessions with engineers from different squads saying, actually, what do you think matters to you? How do you think it fits into our architecture? Shouldn't be something coming purely from management of saying all of these classes need to be tested or not, but actually building it from the ground up to sort of get this support also helps engineers then feel invested in what do I need to test, knowing that the rules will reflect this. And what we found was actually when we did this, we just do not using any real numbers, but sort of a before and after. Of course, your code coverage actually jumps because you add these exclusion rules. Probably the code that you're excluding wasn't tested, and that's why you're excluding it. But actually, this is already starting to give you a much more meaningful measurement, because rather than just looking at it and maybe saying 50% of the code in our app is tested, has code coverage, you're actually now looking at this and saying maybe 70% of the code that matters to us in our code base is being tested. And this, again, really helps sort of the engineering engagement as well. Following this, sort of the next thing that we can do is combine this with static analysis rules, because one of the problems or sort of the challenges that we started facing is okay, you start adding these exclusion rules, but then what you don't want to do is, engineers, everybody, and I very much include myself in it, everybody gets a little lazy. Everybody sort of wants to cut corners at times. You could have all the best intentions in the world, but you'll always have those moments where you're going to try and ship something, it's a late night bug fix, or something you want to put in. So then it's like, how do we actually enforce that the classes that we want excluded from these code coverage contain no testable logic? How do we say that our simple interfaces in our contract modules really are simple interfaces? And there's sort of this concept of cyclomatic complexity. I put the sort of official definition there, but sort of summarized is, it's just a calculation that actually helps you find basically a lower number equals less complex code. So if you have lots of if statements, you have lots of logic in there, you're going to end up with a very high number. And again, not talking about specific tools, but if you look online, there's a lot that you can actually use to generate this, sort of at class, method level. But we're looking for less complex code when we're measuring this. So then, if we go back to the answer of how do we enforce that, or that classes that are excluded from code coverage are simple, we actually combine this measurement and say classes that are excluded should also have a complexity of less than x. So now we're doing it sort of both ways. As the example, we could say when analyzing all our contract modules, they shouldn't have a score higher than this, and it will fail the build if so. So I actually wanted to give a very quick example, putting those sort of couple of previous points into practice to start showing what does this actually mean, as much for like the day-to-day engineering workflow. So I'm going to start, with sort of this when code coverage is not useful. And this sort of leads into the examples that all of the blog posts were written about and that sort of angle. So if we take this really basic Kotlin data class, I'm sure we've all seen something like this in our day-to-day work. And this is maybe just representing an API response, just something where you need to transfer data in your app. Now, by default, if you've just enabled your blanket code coverage on everything, checking it on the build, everything that's checked in, you will check this in, as I have encountered before, and you will get this build failed, sort of, you're not testing your code. And the very easy thing to think to do, if you're just then trying to do it, is you end up writing a sort of test like this. Now, when you look at this, at the beginning, you sort of start seeing this given when then pattern, and you think, okay, this is fine. But when you actually look deeper, we're not testing anything. You're just testing the underlying Kotlin implementation of a data class, which hopefully we should all be able to trust. Kotlin should be, their platform should be testing that themselves. That's something out of everything, we should be able to rely that a data class is doing the right thing if we're setting values and bringing it back. So yeah, the code is tested, but does it need to be? No, it's not providing any value. And when it's taking up this time, in my experience as well, and from personal experience, you'll end up cutting corners. You end up copy pasting tests, you end up just changing a couple of things. You basically are going to do the quickest thing possible to make this test go green, and you probably won't even care. You'll see your build go green, you'll go great, but then again, these tests can be flawed. Even sometimes the code coverage calculations can be flawed, and this actually doesn't give a meaningful picture to anybody. So if we go back now to maybe when we've put some of these rules in place, and you could say, okay, we go back, and this is going back to sort of the exclusion rules, and we say, okay, we had my basic object, and it's failing the build, but now we could actually rename it. If we remember back to our exclusion rules, we'd added one, maybe I forgot to cover in a previous point, where you can do sort of file name levels, where it actually said anything ending in DTO is now excluded. So we've actually just renamed this file. We haven't actually added tests, but we've just renamed the file to match what we would expect it to match. And now the build is succeeding. And then we go in and we add another method. Maybe we're adding some logic here, so we're now concatenating some strings. Again, this could represent anything where actually you shouldn't be doing this. This shouldn't be living within the API representation. You shouldn't have any logic here. And we now try and commit this. We'll actually get a complexity exceeded for our DTO classes. And if we now link this back to the title, supporting your architecture with code coverage and static analysis rules, we can now see that actually through using this, we have our MVVM architecture. We can ensure that, if we take like our DTO classes that are in a certain folder, we can ensure that they don't have logic, they're not complex, and they don't need to be tested. So for any engineer coming along now, you can look at, where do I need to find this data class representation? It's going to end in DTO because that adheres to it, and you actually have the built-in motivation yourself to make sure that all your namings and all your module structure for the code you commit is correct. This obviously can go alongside other linting rules and other tools as your choice, but to me it's a really nice way that actually by building up these sort of code coverage rules, you're enforcing both parts of the architecture as well. And you can also then start combining it with other metrics, not just the static analysis metrics. So some of the things that we've started looking at Skyscanner as well is actually things like programming language distribution. Working on a code base that has a lot of old Java codes alongside newer Kotlin codes can be really interesting to see how tested is the Java classes compared to the Kotlin classes. Is there certain packages or modules in the code that we, have more test coverage or lower? Because if you take two modules, one is 100 and one is 0, you just get an overall number of 50%. But equally, you could have two modules of 50 and 50, average of 50. Again, which one of those should be more concerned? Of course, you want to actually look into, well, there's one with 0%, that's what we care about. Also, last updated date as well. Is it new code that's having high or low test coverage or not? And honestly, when we did this at first, you can actually get some quite powerful analysis purely by putting this into a spreadsheet, taking a dump of the code coverage, kind of putting it alongside some of these numbers, and actually give you a really powerful first pass analysis. But you can use, we actually built some internal tooling to use some internal APIs as well, where you can actually then auto generate this, look at commit timings, GitHub APIs, things like this, where we can actually produce sort of a daily report, which is useful going into sort of the next point, which is monitoring over time and not jumping to conclusions. This is something, again, I've seen on previous projects where, again, as we said, having tests does not mean they're valuable, and you should measure over time, because I had a previous experience where somebody looked at code coverage, said, this number is too low, kind of wanted to jump the gun on why is this low. But when we looked over time, we'd actually seen it had started from a really bad place, and engineers had onboarded, and this was actually increasing steadily. So even though it was still low, the fact that it's increasing is a good thing, and that should be encouraged rather than just saying, it's too low, why is this happening? And again, that sort of really doesn't build this culture of trust between engineering leads and engineers themselves. And when you combine this, we actually managed to get some really interesting insights at Skyscanner. Some things you wouldn't expect. So for example, when we were looking at sort of that programming language distribution, we would think, oh, it's the old Java code that's not tested, our new code should be. But we actually found that a lot of the older code had these really high tests, and it hadn't been touched in a long time because it was sort of what we'd call legacy code, but it was actually tested. And that challenged our assumption, which was our default, which is to go, our new code is tested, it's great, old code, that's the problem, that's why the code coverage is low, don't worry about it. And so sort of to wrap up and bring this all together, sort of what we've seen, so ultimately the output you'll get if you put some of these rules in place, sort of exclusion rules, static analysis, combining, you're still going to get exactly the same graph as before. You're still going to get this number that you can look at, that you can measure over time, but now it has a lot more meaning to it. Rather than just being something where you're saying, well, this represents all of our code base, we know there's certain third parties, we know with our architecture there's bits we can't test on Android, there's bits we don't want to do. We can actually now look at it and say, this is actually meaningful because we know that this represents what we actually care about within our code base. And if you take it from sort of, going back to the different stakeholders you might have involved, from a tech lead and manager perspective, they have access to these reliable metrics, not just sort of, as I said, these random numbers. And they can work with the engineers, not against them, to make sure everybody feels invested. And they can ask these targeted questions, not just, why is the code coverage this? And then the engineer has to say, well, it's just API integration, does this. So actually, why is our Kotlin code that has been committed in this module in the last 6 months dropping in code coverage? Is there something that's going on? Really helping these conversations. For an experienced engineer, it actually helps you get into the investment into this code quality. You're writing the rules and seeing it grow over time and building up the documentation via these decision logs. And for the new engineer, it actually really helps as well. So you have this consistent structure, you can onboard to the code, you can see, and these automated checks really help enforce it through CI. So given I don't want to delay anybody from lunch, I will say thank you very much. Happy to answer any questions afterwards, and check out, we have other Skyscanner talks from my colleagues Maria and Gerardo later today and tomorrow. So go check them out, and thank you very much.